This is a follow-up video on the previous Flux.2 Klein workflows, and I'm adding this workflow with all the others shown in the older videos. Link to the older video will be in the description. The diffusion models I am using here are the Klein 9B distilled model, which should give results in between 4 and 8 sampling steps. And this is a mistake, I will change it. But you should not get confused. This base model will work and will produce a better looking result, but then you will have to change the number of sampling steps in this workflow. Probably from a smaller number like 4 to 20 or 25, somewhere around this. But I will change this link to a distilled model similar to the above with FP8 precision. The third option is the GGUF models, which are placed inside the UNet folder and loaded with the help of this UNet loader. The result generated looks promising to me. This is the subject in this example. And this is the target where I want the subject to be. The result on the right looks good to me, but let's be picky. The right hand became smaller here, which I think is acceptable because I'm targeting the character in this image. The result has been processed further to add details to it. And the details added here are impressive, which makes this 9B model really fun to play around with. The text encoder and the VAE are present here, which should be selected with this red color nodes, specifically in the load clip and the VAE node. You can select a LoRA here in case you want, then the same LoRA will be used throughout the workflow. This float value was necessary because I tried with larger image, and this helped me changing the image size throughout the workflow. I will rename it so the workflow becomes readable. The image 1, which is the subject, goes into this node group, and it says processing subject. The files selected are connected to this reroute node, the model, and then the text encoder. The third connection is for the subject's image. And then the pixel size for the image resize node. And then the last connection is for the VAE. The image generated here is this, without the background. The prompt used here is about replacing the background with a white background. The image received here in this node group is resized by this node, and then it uses the same as a condition to produce a final image based on the given prompt. Our subject can now be easily identified without a background, which will be kept in the target scene. The second image, which is the target scene, goes to the node group below. Again, these are the connections for the model, clip encoder, and then VAE, followed by the image and the megapixel size to adjust the given image. The prompt here is about removing the clothes of the person in the target scene, which is the second image. I tried open pose as well in this case, but that made the workflow more complex, and I saw people mentioning this technique, which was simple, and it works. The workflow works similarly. The image received is adjusted and then used as a condition with a prompt to produce an output. And this output may not look appealing. I should better bypass this preview node. We do not want to save these images. We will be saving the final result. This node group is processing the target pose, or I can say the target scene. So after having both the images, both goes to this node group. Here it says about processing the subject and the target pose to produce the result 1. Again, I'm using the same model, clip encoder, VAE, and this image scale size. These are the two images we saw generated in both node groups. The prompt here can be changed in case you want the subject doing something in the target scene. There is an example prompt from ComfyUI, and this prompt will just get the job done with a similar pose in the target image. The logic is simple with both images going with a prompt, and it becomes a condition where the prompt is about the character from image 1 should match the character in image 2. The output is decoded using the VAE, and this is the result. The result looks great, the character has been switched, and it looks clean. The result 1 is now set in the set node with the image generated by this node group. The result 1 is then previewed here, taken from the get node, visible in the corner. So we are done with this section. Now, in case you're not happy with a face generated, then we have this node group below. The title says, Improving Result 1 Face. Right now, the process nodes are disabled because I'm not using this node group. We have the models, clip encoders, the VAE, and this image scale size. The prompt here is about changing the face of image 1 to match the character's face from image 2. Image 1 is the result generated above, which enters here and becomes a reference condition. The second condition from which we will be referring the face comes from here. And this image of the subject is loaded again, and a mask is created on the face. I will create again by increasing the opacity. Save the mask, and then activate this node. Keeping this node active without a mask will give an error. I will activate these process nodes and run the workflow. Only this node group is working right now because all other seed IDs are fixed. The mask I created gives out the subject's face, which becomes the image 2. Now the prompt will be followed where the model is supposed to match the character's face from image 2. The result is generated, and I do not see any changes, but if you encounter any problem with the face, then you can try this to fix it. I will set this image as an improved face so that it can be used further in the workflow with the help of the get node. So we got the result 1 here, and then we got the improved face here, which may not be used in most of the cases. On the top, we have this node group, which says about adding details to the result 1. If you want to continue with the improved face we got from here, then disconnect the Get Result 1 node from this image scale node. And then I will add the Get node for improved face. Make a connection, and then you can continue with the improved face image. This workflow is slightly different, but nothing special. I am using a prompt that is actually the trigger word for the LoRA selected here. Below, the LoRA node is not in the connection. The connection begins from the diffusion model, and a different LoRA is used above to add details. The LoRA was downloaded from Hugging Face, and this is the safetensor file. It says realistic. I did a few tests on a 3D character, and it does a decent job. You just need to decrease the LoRA weight slightly. I will add a note with a download link. You can save it to the LoRA folder and make sure to rename the file correctly. The details about the LoRA are not present in the model card, but it works. And here I have set the result 2 node with the image generated having details. The result 1 and result 2 are compared here, which looks fine to me. So after getting the detailed image, you may need to increase the resolution. You can connect the image here. This should upscale the image to 4K. To make Seed VR2 work, you will need the DIT model and the VE. Both files will be downloaded automatically by these nodes. The VAE name is selected, and here, out of all these models, one of the models I prefer is selected. There are smaller GGUF models in case you are on a GPU with smaller memory. To get some details on these models, you can search for Seed VR2 DIT models. This video explains in detail about upscaling. It's a 1-hour video. Watch it if you are interested. So on GitHub, scroll down, and you should find the model details. There are 3B models and the 7B models. This will actually be a whole new topic. So all I can say is FP16 is good if you have a strong GPU, or else just get the smaller model. I will run the workflow, and if you are using this for the first time, then you should see the model file download progress, In my case, it's present already. So it took 175 seconds, and the image generated is a 4K detailed image. The workflow works great. This is the subject, and this is the target image. The result generated looks good. The details are added, and the final comparison looks great. What do you think? So that is it in this video. The workflow and the images used will be in the description. I hope the video was interesting and useful, and I wish you an excellent day.